All right, so let's get rolling. Nope. Now we are cooking. All right, so my name is Zsolt Homorodi, and thank you for coming for this presentation. The theme will be how we build cloud-native, GDPR-friendly data collection framework for our project. I will start the presentation with a short introduction to GDPR. So if somebody is not totally up to speed on it, understands why we did the changes, the choices that we did. So GDPR is this new general data protection regulation that became the law in the EU almost exactly a year ago. And it contains a couple of rules and regulations about the privacy of personally identifiable data and how it can be stored, how it can be processed, and what kind of things needs to be ensured on any of the companies who wants to work with this kind of data. It identifies three types of personal data. Normal personal data is just something that is collected about you. Special category data is something that reveals some kind of sensitive information that in the wrong hands already could be used against you. These things are like your ethnic origin, your political views, racial origin, sexual orientation, and things like that. And then the highest level of this law that is related to criminal prosecution. So if your research or your company needs to work with that kind of data, some really, really special rules apply. It also defines the rights of individuals, so the people you are collecting the data about. You need to be transparent of what kind of data you are collecting, why you are collecting it, how long are you going to store that data, and also if you are handing it over to some other third-party data processors, who will get your data, who will get the user's data, and what those companies will do with it. Extra special care needs to be done, exercised when the data leaves the EU zone. So if the third-party processor is in US or China or somewhere else, there are some extra regulations there. The users has a couple of rights that pertains to their data. So they have right to access the data that you collected about them, and in a format that is easily consumable for them, so some kind of standard format like JSON, YAML, something like that. If they find that the stored data is incorrect in some ways or contains incorrect information, they have the right to correct the data or request corrections. They also have the right to opt out of your system and request that all the data that was collected about them needs to be deleted. It also sets the rules for the data controllers. So it requires that data protection is in the system by design. So it's not some add-on, and the data is protected by default. Access control needs to be exercised. So there are certain levels of the data. The raw data should be accessible for as few people as possible, and then you could do things like anonymization or pseudonymization steps that removes the real sensitive parts of the data, still keeping it intact enough that you can do your research. So that is access control. And also it defines rules of what a company should do if a data breach would occur. So it's not enough anymore that after a couple of months you learn from a blog post or somewhere that a data breach occurred in this and this company. there is a quite short window of time when the company needs to notify the local data protection office that each EU country has, and then collaborate with them how the fact that the data was breached is communicated towards the users. And you also need to kind of do an impact assessment. Usually, already during the project planning phase, you do impact assessment that in case of a breach, what kind of problems the leaked data could cause. And then in case a breach actually happens, you need to notify the users that what kind of data was leaked and how it happened. Adopting these kind of rules to our company, of course, happened on multiple levels. So we improved our internal data management and access control system. A company DPO, this data protection officer, was elected. So he is the person that in case a user has some kind of questions or objections about our data collection system, they can contact him and get a service. They can also always contact the National Data Protection Office, which in Finland is an ombudsman. We also created this GDPR handbook that is for the project managers. So every time we are starting a new project, we are doing a couple of things. One is data mapping, and the other is the impact analysis I already talked about. So data mapping is this tool that we are using to understand what kind of data are we going to collect and identify if there is anything personally identifiable in that data set. Because if there is no personally identifiable data, then the GDPR rules don't need to be applied to the data collection. But in case there is, we need to define what is the basis for us to be able to do the data collection. It can be a consent, so something like a consent form you show for the user, and then you collect data based on that. Or it can be a contract between you and your user. And in case, it can be also public interest, so we are allowed to do certain kind of research in Finland that is deemed to be in the public interest. There is a board in Finland who can decide if a project is worthy for that kind of consideration or not. We also defined during this phase what kind of transportation, storage, and archival security we are going to use for a given project. Can we do any kind of pseudonymization or anonymization already during the collection of the data? So we try to remove as much personally identifiable data as possible that still makes the data usable for the research that we would like to do. And then we define inside the project that who will get access to what kind of data and what is their role inside the project. So as I said, GDPR is about a year old right now. So how does it look in numbers so far? So GDPR is enforced in the 28 EU countries, plus Iceland, Norway, and Liechtenstein. So far, there are 266,000 cases that were reported to the national data protection offices. Out of this is almost 100,000 is complaints from users. Then around 65,000 are data breach notifications when companies realize that something went wrong and notify the thing. And then the other is about 50,000. Out of these 200,000 cases, 47% of them is still ongoing because these data protection offices were severely undermanned in practically all the countries in the EU. So they are now extending these offices in some countries like Ireland, where many of the big companies have their headquarters. They had to extend this almost like 40% of their previous personnel. And so far, the EU sent out fines in the count of $55 million to these companies. If you are interested in the absolute details, you can go to this link on the site, and then that's the place where I got this. All right, so let's talk about a little bit how VTT works and, well, what is VTT to begin with. So VTT is the Technical Research Center of Finland. So this is a company that is owned by the state, and we are a non-profit organization. We are doing all kinds of research, so it's not an IT research organization. We have researchers for nuclear safety, biological research, food science, and then the team that I'm working for belongs to this data-driven sciences part. We are having about 2,000 researchers all around Finland, and out of these 2,000 people, around 200 are those who are involved in some way or shape in software development. And yearly we have somewhere between 10 and 20 projects where the project actually needs to gather its own data. It's more common that the data comes from somewhere else. So either in a big consortium project, the data collection is done by some other party, or the data is already existing. Or in customer projects, it's more usual that the customer brings their already existing data, and we work on that. But for these projects that need to collect their own data, we wanted to create a generic enough system that at least parts of it can be used in multiple projects, and then some projects can use the whole system as is. And why we do this is that inside VTT, there is no ops organization where a project could hand out its own, let's say, developed servers and ask the ops that please run this for us in productions. Instead, and this is because of historical reasons, the company is set up in a way that each project is its own functional entity that owns everything that happens inside that project. So we need to do the software development, we need to do the data science part, we need to run our servers, and then at the end of the project we need to do the archival work, and then that we can hand over to the IT organization. And the goal was to empower the researchers, because most of the people in the company are not like me. I'm a software developer. My job is to develop software for my team. But most of the people in my team are researchers. They are data researchers, behavior researchers, and so on. And they are experts in their field. And the best way to utilize their talent is to let them do what they do best. So because of this, we wanted to create something that is easy enough to use with very little Kubernetes knowledge. So they don't need to know much more than how to create a container, how to write a deployment descriptor and a service descriptor, and practically that's it. The rest, as I will show in a couple of slides, is handled for them. So we selected a couple of areas that we wanted to definitely do. And the first one was automated provisioning. So we didn't want to write like a wiki page that you need to follow these steps. We want to give a tool that you run it, and then it provisions your environment. We wanted to have some really lightweight monitoring that, again, doesn't need some extra setup from the user. It just comes when this system is deployed. We wanted to have like security in place. As I said, the EU regulation practically tells us that this is a necessity. So we wanted a Ingress, and we wanted it to do TLS termination. And then inside our cluster, because we are sometimes running these clusters in the public cloud, we wanted to make sure that between the services, the data is also encrypted. So we wanted mutual TLS between the different services and as easily as possible. And then the system had to be like customizable. So there are these Lego-like parts that you can choose to use or choose to not to use. And we also provide some components that I'm not going to show today. So these are components that we created for internal use, at least for the time being. So we have a timestamp key value store with optional encryption and location data storage. We are using OpenID Connect for authentication and authorization. We developed a couple of components taken from previous projects. So one of them is location anonymization that we can utilize if we have to collect some kind of location data. We found that often it's enough if we identify areas that a person visits often, and we label them like 1, 2, 3, 4, and it's enough for what we are doing. So that tool does that. We have various kind of pre-processing tools that simplify the use of the data. Usually our developers or researchers are working with Python. So the output of this pre-processing is a kind of data that is easy to load in Python libraries, so something like Pickle or something like that. And we also created an Android application that acts as a sensor data collection gateway, because my team usually does science around human data. So we are collecting things like, what is it called, like health watch data, like your heartbeat, your perspiration levels, your phone usage and things like that, and we try to draw some conclusion from that. And this project is not a standalone project that just develops this tool, so it lives inside other projects, and we try to identify what could be a reusable component, and then we develop it in a way that it's not tied to the given project's goals, but reusable. And then we try to refine and extend it based on user feedback. So our timeline is this, but before we continue, I would need to start, if I would see this thing, because I would like to show you a live demo of the system, and it will take a bit of time to start. So let's start it up. So this tool that you are seeing is called Pulumi. I will talk a little bit about it later. But we need to wait first. There is one first step here that sometimes there is a synchronization issue between the tool and Azure. So I would like to wait until we are through that step, and if it works, then we just continue with the presentation. Okay, it looks alive. So let's continue. So we started this project with early experiments in 2017. We had a proof of concept for the pipeline at the end of 2017, and then I came to KubeCon last year to Copenhagen. I learned a lot. I've seen a lot of good ideas, and I took that home and we continued developing the system. So in September 2018, the first version went into production. Again, we are a research institute, so our production levels are a bit different than you hear in most of these talks. Our, biggest research thing has like 5,000 users when we are collecting data, so we are not exactly a biggest Kubernetes users in the size of our clusters. Most of our clusters stay within like the 5, 6 number of, the node number is around 5, 6, and then it's perfectly enough for us with much room to breathe. So there is that. And I'm now working on this second version of the pipe, or 1.5 version of the pipeline. The biggest step that we are integrating at the moment is a service mesh, as I will show it a little bit later. So let's talk about the components. What are the pieces to this cluster puzzle? So our architecture looks something like this. There is that Android application that acts as a gateway. We have an Ingress controller that is already inside Kubernetes. And it's also meshed into Linkerd. So we are using Linkerd 2 as our service mesh. And then inside those components are the ones that I said that they are not open source or not open source yet. So we are not going to see those ones. So what kind of components did we select for our system based on some of our needs? So the first part that is important for this whole cluster is that we wanted to use GRPC as our RPC protocol. So GRPC is based on HTTP 2. It has a protobuf-based data object service definition model. So you can define in this protobuf file what kind of data will move through the wire and what kind of services do you want to have. And then both the server bindings and the client bindings are automatically generated from this definition. This is a protocol that originates from Google, and it supports a lot of target languages. The most important for us are Java and Python and Node.js. It's a really effective binary representation. When we switch from JSON-based data protocol to this gRPC one between the Android application and the servers, we gained around 30% throughput, which was really important when you are trying to gather a lot of raw data. Like we try to gather raw heartbeat data with raw accelerometer data and things like that. So we don't want to rely on the heartbeat algorithms that are developed by the companies who put out these watches and bands and things like that. Then it's really important. And lately, there is this new standard called gRPC Web. So it brings gRPC also to the web client world. So now you can do like end-to-end systems using just gRPC. And this is an important thing to keep in mind when you are selecting the next component, which is an Ingress. So you can, of course, expose a gRPC-based service with the standard service object in Kubernetes, but there is a little bit of a problem with that the gRPC, the service load balancer that is created when you create a service object, that's a layer 4 load balancer, which means it's really good when your connections are short-lived, like an HTTP request. But in case of a long-lived connection system like HTTP2, where there is one connection that is kept between the client and the server, and then the requests and responses are just going on this one connection, then the load balancing happens in a way that it's load balanced in a sense of the connections are balanced between the service instances, but not the actual request rates. So if you have clients that are sending the exact same amount of data, it will work. But if there are clients that require less data or produce less data, the others produce a lot more, then this load balancing practically doesn't work at all. So you need something that understands a protocol and can do protocol-level load balancing. We needed something that can take care of TLS termination. And because I had previous experience working with Envoy, I wanted to work with something that is based on or based around Envoy. So that's why we started to try these three. The original 1.0 version used Heptio Contour, or now VMware Contour, I guess. We are moving away from that, not because there is anything wrong with it. It worked really well. The problem we have is that when we want to integrate it with the Linkerd to service mesh, we need to change or add a header to the request. And that's something that at the moment Contour is not capable to do. So you cannot define additional headers for the request or the responses. So we had to try to work with something else. In the demonstration, if demo guts are with us, the demo uses Ambassador. And I'm working on the Glue integration. It's almost there, but I didn't have time enough to finish it before the conference started. So everything works except gRPC web. So gRPC itself, the normal gRPC works, but gRPC web doesn't. And one thing that you could keep in mind when you are choosing your own Ingress controller is all of them offers features way beyond the normal Ingress object that Kubernetes defined. So Glue, for example, offers like read-write, fault injection for testing. It can do real complex transformation of the request body and the header. Ambassador offers like circuit breakers. And Contour, it has like a hierarchical configuration system where you can like define the basic stuff on the default namespace, and then you can delegate part of the Ingress tree practically into different namespaces, so you don't need to give rights for all of your users to be able to manipulate the root Ingress object, but you can give them rights that inside this namespace you can define your own, and then it will always appear under this path or things like that. So these are really excellent open source projects with super nice communities. Then the TLS certificate management, we wanted to use Let's Encrypt. And inside Kubernetes, I think probably the easiest way to do it is JetStack's Cert Manager. So we are using it. It supports both the HTTP and DNS-based validation. The small caveat there is that if you want to have HTTP validation, then you need to have an Ingress controller that actually works with Ingress objects. Because I forgot to tell you here that both Ambassador and Glue, they offer their own object instead of Ingress. Glue itself can be installed in a way that it supports normal Ingress objects. Ambassador, as far as I know, doesn't. So it uses a different mechanism how you define the same kind of thing that Ingress does with some extended features. Contour itself does support Ingress. And then if you want wildcard domain names in your TLS, then you can do that only with DNS-based validation. Then the next component we selected is a service mesh. So originally we wanted something that we can use for monitoring. And one of the key things that we wanted to have is that we don't want it to have any impact on the service code and as little impact on the definition of the service object as possible, because we want to really keep it simple for our researchers. So, and also we wanted something that provides a dashboarding out of the box, so we don't need to always create it for every single project. And as I said, we are not running the largest Kubernetes clusters ever, so we wanted something that is lightweight both on memory and CPU. So we selected Linkerd. Originally, we didn't think about MTLS as a feature that we really want to use, but when some of our projects started to work with those sensitive data that I talked about in the beginning, there practically it's a necessity. It comes with some performance penalty, but it works really well for us. And it has some extra features that we are not utilizing, something like retry budget, for example. And okay, the next step is what keeps the whole installation, or brings the whole installation process together. So Pulumi is this quite new infrastructure as a code tool. If you know Terraform, this is very similar. Actually, the tool itself uses Terraform in some of its providers. What is the really big change here is that you are using actual real programming language when you are putting together your infrastructure code. So no more templating languages. This one uses or supports JavaScript or TypeScript or practically any language that can run on top of Node.js. And Python at the moment, as far as I know, there are plans to support Go at some point. It finds the dependencies between the different objects that you are deploying automatically most of the time, but you can also define manual dependencies if you want. And then they wrote a really great Kubernetes provider that supports 3 ways to define Kubernetes objects. One is programmatic, so they have an API that you can use. You can use your Helm charts. It uses a locally installed Helm in templating mode. So it generates from the template the output. It doesn't use, what is the name of, well, the server-side component of Helm. And you can also use just simple YAML files that you already have somewhere. And one difference between how Pulumi deploys objects to Kubernetes compared to when we are using kubectl to send our YAML files is that it has a logic inside that waits for completion. So, for example, when you create a deployment, it validates that the deployment actually created live pods that are ready. Or when you create a service object, it only passes if the service object has pods behind that can actually serve the cluster. And it waits until these conditions happen. So you can be sure that when you install the next component and next component, they can already talk to these previously dependent components. And then the last component that I would like to talk about is Orgo. So Orgo is this workflow engine for batch processing. It's totally based on containers, so it's container native. You can create multi-step workflows as long as you define it as a directed acyclic model or graph. You can create, it understands which steps can be executed parallelly. The workflow definition can be parameterized, so you can use it practically as a template and then run it with your parameters. And it has some conditional logic inside, like loops, conditionals. And then whatever was created during the workflow as an artifact, it can be uploaded to storage like S3 and similar things. Okay, so let's see where we are with the demo. Oops, there is some error. Oh no, this is... So this is the error I talked about. It just happened way later than I thought it will happen. The problem, as you can see, there is still a lot of work to be done, so I'm not sure. I created like a recording of this, but with the recording I won't be able to show the live system, so I'm not sure how much time we have still. Do this. I think I'm practically running out of time as it is, so let's switch over to to the recording. So it's a quite a bit sped up recording, but you can see how Pulumi works in action. The error also happened in the hotel yesterday, but in the hotel I found it much quicker, so I could. So as you can see, it creates everything. So it first creates a Kubernetes cluster with the necessary service principals and passwords. It works in Azure. And then it will create the Kubernetes cluster itself. And then let's jump a little bit ahead, because we don't need to wait for that. That takes something like 7 minutes in real time. So, all right. So as you can see, then we are putting Linkerd and Cert Manager into use. And on that side, that's the waiting logic. So what is happening there is it waits until the services have enough pods behind them, and then the deployments have the necessary requested amount of pods themselves. And once Linkerd and Cert Manager are ready, then it installs the Ingress controller, and then it puts the application inside, and then that's it. I guess I will have to stop at some point, but will somebody tell me? We can go, I guess, until somebody kicks me off from this stage, and as long as you guys are staying and watching. So let's see how the real system does. Not so well. Yes, and then once the Ingress controller is there, so we now have an IP address, a public IP address. We take that IP address, register it using a DNS provider, in our case, Cloudflare. And then once we have the DNS name, that's when we can generate the certificate. We generate the certificate through Cert Manager. It creates it as a secret. Then it's fed back to the Ingress controller, and then the Ingress controller ambassador will start to use it as the TLS termination certificate. And then the last couple of things that I wanted to show you guys is our own application, but I guess we will not have time for that. The good news is that this whole thing is open source. So if you have an Azure account, let me show this. So quickly, if you go, the next one. So if you go to this GitLab link, it's a monorepo that contains everything. So the provisioning tool, the demo application, a web application that would be used as a kind of like a load generator. So everything is there. And please give it a try. I'm sorry that we run out of time. This is first time for me to talk in a big audience like this, so I guess I was a bit slower than I expected. So let's see, there we are. Oh no, this will never end, I think. So who is coming here after me? Please come, guys. I can stop. Thank you very much.